Former NASA Science Director Thomas Kinn shared his thoughts on the launch of the James Webb Space Telescope, heralding the beginning of a new era in astronomy. Webb was poised to expand and test our cosmology, our understanding of planets, and the origins of life. But what started with hope quickly turned to devastation. James Webb has shocked scientists with a crisis that could get worse before it gets better. Will the telescope's new discoveries bring answers or feed physics into a deeper debate? Will the debate over old theories end, or will we just end up with weak explanations? James Webb, an $11 billion project, had to bring solutions. Instead, it is plunged into the kind of crisis of cosmology we last saw in the Middle Ages, when we moved to a heliocentric worldview. Now we may have to admit that the foundations of our modern physics are incomplete and that we have come no closer to understanding what our cosmos really is. How is that possible? Today's astrophysics, or the science of physical quantities and relationships in the cosmos, is based on fundamental laws of physics that go back to ancient, medieval scientists, and especially Sir Isaac Newton. Newton discovered gravity, the cornerstone of astrophysics, and we built our scientific observation of the universe on those foundations. But as the observable universe expanded, the quantities we knew no longer matched what we saw. That crisis began with the problem that different methods of measuring the age and expansion rate of the universe led to conflicting results. Local measurements based on astronomical objects gave different values than measurements of the early universe based on the cosmic microwave background radiation. This dissonance, known as the Hubble stretch, challenges our understanding of the rate at which the universe is expanding. In the summer of 2022, Webb found so many old and advanced galaxies in space that the age of the universe was questioned. Our cosmos can hardly be 13.8 billion years old when Webb shows us galaxies that were already well-developed 200 to 300 million years after the Big Bang. According to our physics, galaxies take billions of years to grow. Webb's observations indicate that some galaxies may have formed before the Big Bang, challenging our old cosmology. This cosmology assumes that the universe began with the Big Bang 13.8 billion years ago, has expanded since then, and has undergone slow matter evolution. If not, we are at a crossroads. Either we have made a mistake in applying mundane physics to the entire universe, or we have understood only a small part of the physics that actually exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this maxim, all the physics of space should also be located on Earth. But perhaps we have overlooked the forces and dimensions on our planet that we now perceive in space. Webb's technology breaks all records. Capable of picking up very weak light signals, the telescope's 18 cell-like mirrors detect light that has traveled through space and time for more than 13 billion years. A special exposure method makes these weak spots visible for the first time. Thanks to this evolving technology, we have seen light from the most distant galaxies that formed shortly after the Big Bang. In the summer of 2022, these galaxies were a sensation, but also a bitter disappointment. Instead of small galaxies, Webb showed fully developed galaxies that appeared to be several billion years old. At 13.5 or 13.6 billion years, that could never happen. Scientists today sometimes say that objects in Webb's images are impossible or not real. But Webb can only show us the truth. Science must now admit that it has apparently been on the wrong track for over a century. Our cosmological standard model is about that old. What we see here is real, and Webb does it perfectly. It's just that much of our science still cannot accept these new truths. Some traditionalists strongly oppose the idea of an end or expansion of the Big Bang. In the Middle Ages, it took years for the Church to accept that the Earth was not the center of the universe, despite astronomers across Europe presenting evidence. Not much seems to have changed today. Scientists who proclaim something new may no longer end up in prison like Galileo, but controversy and hostility to new ideas continues. Imagine spending your life researching and believing in something, and then suddenly you see pictures that tell a different story. Your mind may rebel against it at first, and it will take time to accept the new truth. Some adapt faster, while others take longer. Many open-minded young scientists are excited by Webb's discovery. Scientists like Z13 Galaxy discoverer Rohan Naidu and MZ Galaxy discoverer SFL Stein belong to that open-minded generation. They view Webb's images with an open mind and have studied them since they were published. Both astronomers emphasize that we cannot know what is happening in astrophysics right now. We are still waiting for measurement results, investigations, and the latest images from Webb. One of the biggest controversies in modern cosmology concerns the Hubble constant, the rate at which the universe is said to be expanding. In the 1920s, astronomer Edwin Hubble observed that distant galaxies were moving away from us and concluded that the universe was expanding. This idea was extended by the Belgian astronomer Georges Lemaître, who suggested that this expansion started from one point, the Big Bang. Today, alternative methods show that the motion of galaxies can be explained in different ways, giving a unified picture. However, these alternative ideas were ignored for a long time because the old theories were considered more likely. The more we see of the universe, the more obvious the differences become. It didn't start with Webb. Even 20 years ago, there were regions in space where the expansion behaved differently, sometimes faster, sometimes slower, denser, or more empty. This has led to speculation that there may have been multiple origins, or that our universe is fueled by multiple sources, all of which may not have started at the same time, or at all. Alternative ideas emerged about the shape, nature, and age of the universe, but scientists still stuck to the old Big Bang and expansion theories. This was probably a mistake that we briefly learned about the Hubble voltage, which shows clear differences in how we measure the distance of the universe depending on which fixed points we use as measurement constants. Now scientists hope that the Webb telescope will resolve this tension by accurately measuring the distances and redshifts of galaxies. Correcting the errors of previous measurement methods represents a decisive turning point and promises a paradigm shift that will usher us into a new era of advanced physics that permeates the fabric of cosmic reality. This monumental achievement is a testament to the dedication and persistence of generations of scientists who tirelessly push the boundaries of human knowledge. In their relentless pursuit of truth and understanding, these explorers have broadened our horizons and enriched our collective consciousness. As we stand on the edge of this new frontier, it is our duty to approach each revelation with an open mind and embrace the potential of even the most unknown discoveries to shape our understanding of the universe.
The emergence of new theories heralds a new era in research, where established paradigms are challenged and bold new ideas challenge us. We are on the brink of a profound scientific revolution, exploring the oldest points of light in the universe and revealing the deepest truths about existence itself. Thanks to cutting-edge technologies such as the James Webb Space Telescope, we are ready to embark on an unprecedented journey into the cosmic tapestry to unlock mysteries such as accretion disks, supermassive black holes, and cosmic phenomena that shape our universe. As we traverse this bold path into the unknown, we must proceed with caution considering the complexities and uncertainties that lie ahead. Each new revelation brings new questions and challenges that challenge us to face mysteries that have so far eluded us. Each discovery enriches our understanding of the universe and our place in it. This exciting journey with the James Webb Space Telescope marks a pivotal moment in history. The discoveries that await us could revolutionize astrophysics and inspire future generations to push the boundaries of human knowledge. Webb's observations provide important insights into the formation of galaxies, the evolution of stars, and the conditions necessary for life on other planets. By studying distant exoplanets and studying their atmospheres, Webb offers unprecedented opportunities to look for signs of habitation and even life beyond Earth. Webb's advanced instruments will allow us to study phenomena such as black holes, gravitational waves, and the distribution of dark matter with unprecedented precision. These observations will test and refine our current theories of cosmology and physics, potentially leading to a paradigm-shifting breakthrough in our understanding of the fundamental nature of the universe. As we embark on our journey with the James Webb Space Telescope, we are at a defining moment in human history. The discoveries that await us could revolutionize astrophysics and inspire future generations to reach for the stars. Webb's unprecedented ability to peer into the depths of space and time promises groundbreaking discoveries that will transform our understanding of the universe and our place in it. As we stand at the threshold of this new era, let us embrace the journey with optimism and curiosity, knowing that each new discovery brings us closer to unlocking the mysteries of the cosmos and unraveling the mysteries of cosmic evolution.